Hello, guys. Welcome to Eka Science Confab. In our today's class, we are going to be dealing with chemistry. As usual, I believe you know that Eka Science Confab is always about, for now, is always about chemistry. Now, in our today's chemistry class, we are going to be talking about types of chemical reaction. What is chemical reaction all about? When we talk about chemical reaction, in short, chemistry, we are talking about reactions, reaction in different ways. Now, today is going to be we are going to be dealing with what? Chemical reactions, adding A to B to get C. So all these reactions, they are grouped, they have their own types. Now let's start with what we have here on the board. Types of chemical reaction. 1, combination reaction. 2, thermal decomposition reaction. 3, displacement reaction. 4, decomposition or double decomposition reaction, sorry. Number 5, catalytic reaction. Number 6, reversible reaction. Number 7, thermal dissociation reaction. Number 8, oxidation and reduction, or you call it redox reaction. So these are 8 different types of chemical reaction that we will be dealing with. Now we will take them one by one. When we take the first one, combination reaction, we will analyze what combination is all about. We'll go to the next one, take it, and then tell you exactly what it's all about. Number 3, the same. Number 4, till we get to the last. So focus your attention and then pick your point. Now, let's take the first one, combination reaction. Combination reaction is a type of reaction that has to do with what? Bringing two things together to form one. The reactants are two, A plus B. The product is just one, maybe C. So that's combination. You are adding A and B to get C. For example, if I say Na plus Cl2 to give me NaCl, then you balance the equation, because very soon we will go to that. You may not know why I am putting the 2 there and why I'm putting these 2 here. When we get to balancing, you will understand that. So, but for now, this is one, this is another one. Adding 2 together to get one product. We call this product, we call these 2 reactants. 2 reactants combining to get one product. That's what that's what all about combination reaction. This one, I am just using element and element. We can as well do compound and compound. So like when I say PbO2 reacting with SO2, this is a compound, this is a compound. You will now get PbSO4. So this is one product, but formed from 2 reactants. When you react 2 substances, you must get one product, and that gives you what? Combination reaction. Now, good, I believe you understand that. Now let's go to thermal decomposition. Thermal decomposition has to do with heat. Remember, thermal means what? Heat. So by the time you carry heat, you use heat to break a compound, one molecule, into fractions, into smaller molecules. That's what thermal decomposition. Using heat to break one molecule into smaller molecules. For example, if I use something like CaCO3 and then get CaO plus CO2. So I am using heat. This triangle stands for heat. To heat this substance to get this and this. When you use heat to heat a substance, one reactant, and then you have more than one product formed, and that is what? Thermal decomposition. Next is displacement reaction. The one we call displacement has to do with removal of something and then you put another thing there. Just like when you have a team playing football, if somebody is weak, what do? Do you add somebody, another new body into the team without removing anybody? No, you displace this one with this one. Take this one out, fix another thing. So that's exactly what happens here. For example, if I have CuSO4, I can displace Cu using Zn to give me ZnSO4 plus Cu. This man displaces this man in this compound to form this, and the copper that was displaced stands alone. So that is an example of a displacement reaction. Note also, this is just for metal displacing a metal. We can as well use a non-metal to displace another non-metal in a compound. For example, if I say Cl reacting Cl2 reacting with Kbr. This is a non-metal. This is a non-metal in a compound. So this now can displace this to form KCl plus Br2. Now, as usual, when you write equation, you balance that equation if it is not balanced. Cl here is 2, Cl here is 1. So I put 2 there to make it 2. K is 2, K is 1. Put 2 there to make it 2. Br is 2, Br is 2. So that's a balanced equation. So you can, in displacement, metal can displace a metal, like in this case. Non-metal can displace a non-metal, like in this case. Note it. Now, let's go to the next type, and that's what? Double decomposition reaction. When we are talking about double decomposition reaction, we are talking about two reactants breaking. A breaking into two, B breaking into two, then positive each. After breaking, you have positive and negative, positive and negative. So now the positive of this A will take negative of B, positive of B will take negative of A to form two different products. For example, if I say AgNO3 plus NaCl. If you break this into two, this is positive. The whole of this is negative. Break this into two, this is positive. Na is positive. Cl is negative. So Ag, which is silver, which is positive, will take Cl, which is negative, from this one, while to form a compound, while Na will take NO3 to form another compound. This is a double decomposition reaction. You started with two reactants, you are ending with two products. Note it. Next is catalytic reaction. What do we mean by catalytic reaction? The catalytic reaction has to do with a reaction that you use something to push the reaction. If the reaction is very fast, you can use a substance to reduce it. If the reaction is very slow, a slow reaction, you can use a substance to speed it up. That's a catalytic reaction. That substance you are using is known as a catalyst. What is a catalyst? A catalyst is a substance that alters the rate of a chemical reaction. It can either speed up or reduce the rate or the speed of a chemical reaction. So that's catalyst. I have for you some characteristics of a catalyst. Number one here is that catalyst alters the rate of the chemical reaction. The next point is that it remains the same at the end of the reaction. Next is that it is specific in action. This particular one, let me explain it. It is specific in the sense that because A is a catalyst, B is a catalyst, and you want to carry any reaction, you pick any of them and put, expecting it to function very fine. No, they have a particular reaction that they can function very well. They can function in more than one type of reaction, but not in all the reactions because A is a catalyst. You bring it, it will not work in all. So that's the reason we say that catalyst is what specific in action. Next is it does not start a reaction. Catalysts function well in a reaction that is ongoing, not when the reaction has not commenced. You are now introducing a catalyst, hoping that catalyst will kickstart the reaction. No, the reaction is on or must be on before the catalyst can function very well. Next point is that it does not affect equilibrium position. Yes, you may find it a little bit difficult in understanding what I mean by equilibrium. Catalyst will not make you to have more product than you're supposed to have because you have put catalyst. No, just put the catalyst, you quickly get to equilibrium, but not that it will give you more product. You get to the level that you have produced your product, but it will only get or push you to get the product or the result very fast and not to increase the result or the product. So the last one here, it does not affect the type of product. A plus B, if it will give you C, putting a catalyst, using a catalyst will not make it to give you D because you are using a catalyst. It will still give you what? C. It will not affect the product. We have more characteristics of a catalyst than this, but I've given you 6 there. You can find out the remaining one. Next is reversible reaction. Reversible reaction. When we are talking about reversible reaction, we are talking about a reaction that can move to the right and return back to the left. A will react with B to form C. C will decompose to form A. Or if I like, I can say A reacts with B to form C and D. So D will also, if you check my arrows, when we are talking about reversible reaction, we use double-headed arrows. One is facing this side, one is facing this side, meaning that A will react with B to form C and D. That's forward arrow. Now C will also react with D to form A and B. So now the reaction is like going forward, coming backward, going forward, coming backward, going forward, coming backward. That's the type of reaction that reversible reaction is telling us about. Example, you have something like NH4Cl, ammonium chloride. When you use heat, if you apply little heat on it, it will break or decompose into NH3 and HCl. Now, when you allow both of them are gases, when you allow both of them to be together and you cool their temperature, they will now come back together to form this. So this will decompose by heat to form this, and this will recombine by cooling to form this. This is solid, this is a gas, and this is a gas. So that is what? Reversible reaction. Next is thermal dissociation. I want you to note that one equation like this can stand in for more than one type of reaction. One equation can stand for more than one type of reaction. We were talking about reversible reaction before now. Now, I can still use in thermal dissociation, I can still use the same equation I was using there, NH4Cl breaking to form or decomposing to form NH3 and HCl. I can still use this same equation in thermal dissociation. Thermal dissociation, you are still using heat to dissociate this to form this and this. Now by cooling, you are getting back this. So what this thermal dissociation means, and let me, I think if I differentiate between thermal dissociation and thermal decomposition, you will understand it better. Now, thermal decomposition, if you remember the equation that I wrote had one arrow. The arrow is always facing the forward, the front. Whereas in thermal dissociation, the arrows are two. One is facing right and one is facing left, meaning the product can recombine to go back to the reactant. Whereas in thermal decomposition, forward ever, backward never. So now here you can have this and this from dissociating this, and by recombining them by cooling, you recombine them to get back your reactants. The next is oxidation and reduction. Redox reaction. If you cannot call oxidation and reduction reaction, you can quickly call it what? Redox reaction. I think this one I will start it in our next class. I will start with it in our next class. So just prepare your mind and then come, because that one is broad. I want to start it with that time that your spirit is still high. So please, what I wish you to do, subscribe to the channel, watch those videos, ask questions. If you have any question, go to the comment section and drop your question. I will do well to attend to your question, and your life will never remain the same. Thank you.